My name is Rooh Khurram and I work at the KAUST Supercomputing Lab. First, let me thank our collaborators, Ansys and Fluid Codes, without whom these trainings were not possible. They have been our reliable partners in the training KAUST and in Kingdom students are receiving for the last many years. Since 2017, KSL has conducted 7 training workshops related to engineering software in partnership with Ansys. The popular workshops were attended by over 400 people, including 274 individuals from in-kingdom institutions other than KAUST. In addition, 188 students received Ansys certificates that were introduced at the 4th workshop in April 2019. Looking back, the event evolved from a simple one-day workshop to a major forum for engineering simulation users in the kingdom. The first workshop was held in April 2017. In addition to KAUST researchers, the workshop was attended by 13 institutes across the nation. The speakers gave lectures on the functionality of Ansys that could be applied to various industrial problems. The attendees were also given hands-on training sessions on using Ansys on KAUST state-of-the-art supercomputer Shaheen II. Following the similar theme, the second workshop took place in February 2018. The training session consisted of 3 modules, namely basic training on how to use Ansys on Shaheen, success stories of Ansys-based projects on Shaheen, and advanced training on reduced order model and deep learning. Based on the feedback from the attendees, the workshop theme was modified for the 3rd workshop by adding a user group meeting. The 2-day event was held in September 2018. During the user group meeting, Ansys users from KAUST, SABIC, and Saudi Aramco presented their research. Ansys presenters gave presentation on the latest features of the software. Training sessions were held on the 2nd day. The 4th workshop took place in April 2019. A certification program was added in which 55 attendees were given a 2-day course. After passing the certificate exam, 44 participants were awarded certificates for passing the Introduction to Ansys Safety training. On the 3rd day, hands-on session on Ansys functionality and its use on Shaheen were given. A certificate program on structural mechanics was a part of the 5th workshop that was held in October 2019. The workshop started with a user group meeting on the 1st day, certification program on the 2nd day, and concluded with a series of lectures on fluid structure interaction, electromagnetics, and high performance computing. After passing the certification exam, 22 participants were awarded certificates for passing the Introduction to Ansys mechanical training. 6th workshop was the first online event for obvious reasons, which attracted over 100 attendees. The main theme was basic CFD and electromagnetism. The attendees were also given were also shown how to transition their workstation workload from Shaheen to Shaheen. The theme of the 7th workshop was multi-phase flows and structural mechanics. The 2 certifications were offered to the attendees. Let me share some statistics about all of you who registered for this event. Majority group represent non-KAUST academic researchers. There is a sizable amount of KAUST researchers as well. In addition, Saudi industry and national organizations are also participated. We are also seeing a new trend in the online events. International audience is also present in significant numbers. Here are the names of the organizations that are represented by you. Here is a breakdown based on your professions. Students are majority, but faculty and researchers are also presented. Your specialties are aligned with the workshop theme. Most of you are CFD or structural mechanics people. You will learn in this workshop how to couple fluid and structure to do fluid structure interaction problems. 1/3 of the registrants are Ansys users. Rather, 2/3 of the registrants are Ansys users who are looking to improve their skills and transition to HPC. Others are probably experimentalists looking to verify their experimental results and simulation, or someone transitioning from other courses to Ansys, or students who are starting their simulation careers. Only 13% are Shaheen users. Shaheen is KAUST supercomputer that is managed and supported by KSL. Only small fraction of you are running Ansys on Shaheen. Most of you are, however, interested in running Ansys on Shaheen. Now let me take a quick look at the agenda. There might be some minor changes that will be done, and you can get the latest version of the agenda from our website. Shaheen is typically used by researchers to reduce time to solution for their large CFD problems. Most of you are either not familiar with the benefits of running Ansys on Shaheen or are facing difficulties in transitioning to Shaheen. We will have a hands-on session on the first day about that, and I will also explain how non-KAUST researchers can use Shaheen for Ansys simulations. Moreover, there is a lecture from KAUST researcher, a general purpose lectures from Shaheen experts on meshing, Ansys Granta, multiphase flows, and Ansys OptiSlang, which is a robust design optimization tool for oil and gas industry. The FSI training session will start on day 2, which is May 31st. There will be an overview on geometric modeling and meshing, which is general for everyone. And then you will learn about two-way FSI coupling and thermal FSI coupling. Moving and deforming meshes are critical component of FSI simulation. There will be a session on that, along with 3 hands-on workshops throughout the day. I encourage you to follow the instructions and try to do all hands-on session yourself, because at the end of the 3-day event, there will be a test and you will be asked questions that will be covered during all 3 days lectures. So the FSA training will continue, and then at the end of the 3rd day, you will have a certificate exam. I will be sending you instructions about that exam through email. Here is a introduction to the speakers. Ajay will cover FSI training. I will cover HPC and Shaheen hands-on session. Maria will present Ansys Granta. Renee will talk about OptiSlang. Alessandro will present fluent meshing. I urge most of you to attend fluent meshing, because this is really, really cool. And this is a very general purpose. So either you are not in fluid or not, you still need to attend that. Munir will talk about coupling CFD and discrete element method for modeling multiphase flow, and Abhinesh will present her research on design of dehydration module using an integrated experimental and computational approach. Just a quick reminders. I would just say that just keep visiting our website for any new information. It might be difficult for me to keep sending the email, so you just keep visiting our website. For any urgent question, use this email to ask questions. But again, our ability to respond to your questions will be limited. It will be better to use chat for urgent things. So Ansys exam will be given to you via email after day 3 training. That is Tuesday, June 1 at around 4 p.m. Saudi time. The test will consist of multiple choice questions. I mean, it will have FSI component and some HPC component and some question related to Shaheen. But all of the material will be covered during the training. Please be attentive during the lectures and training session. The exam is open book. You can use your notes and all the training material that we have provided. But you are expected to do it individually, so no group exam, please. The certificates will be sent to the successful candidates via email. I wish that we can start seeing each other physically, but well, maybe next time. So if you got the link of this workshop from a colleague and you have not registered, please register in order to add your name to the mailing list so that you can keep getting our future invites. You have received instruction to install Ansys on your workstation and the training material, so you should be all good to go. For some reason, if you are not ready, you can still see the demos and you can go do the training later on, because we'll be providing you the recorded material. Please keep your mic muted throughout the workshop. Use the chat box for asking questions. You will be receiving important information via emails and including the feedback form. That is really, really important. You really need to provide your feedback, honest feedback about these events so that we can improve. We have uploaded these slides on the workshop website along with other material. Just again, keep visiting our website. Now I will introduce Kiran, who will be introducing Fluid Codes, who are our partner. Over to you, Kiran.
Thank you. Good morning, all. Thank you for joining us for 8th Ansys KAUST workshop. I believe we are going to have a very useful and informative session today. I would like to take this opportunity to a little bit introduce Ansys as well as Fluid Codes. To start with, my name is Kiran Srivasthava. I am the academic account manager at Fluid Codes. I am responsible for sales and business development activities for academic institutions and organizations across the Middle East and Africa region. So through this slide deck, I would like to a little bit give you an introduction about Ansys as well as Fluid Codes, and also shed some light on Ansys new acquisitions and partnership. As you all know, Ansys is a gold standard computer-aided engineering or engineering simulation analysis tool, which is being used by many organizations across the globe in their engineering and as well as product development activities. As you can see, like, it has 50 years of legacy in the engineering simulation domain, and it's been recognized by Fast Company as one of the most innovative companies for 2021. Ansys is by far focused in order to help our clients and valued prospects in their leading product technologies in almost all physics areas. Either it could be fluids or structures or electromagnetics for that matter. We have more than 45,000 plus trusted customers worldwide. 97 out of 100 Fortune 100 industrial companies leverages Ansys capabilities in their engineering simulation activities. Of course, it is ISO certified tool, which is continuously improving year on year. And also we are a very prestigious member of Standard & Poor's 500 list with $12 billion plus dollars of market capitalization. In order to make this happen, we have like 2,900 or 3,000 plus employees globally, placed across 75 offices in almost 40 countries. In terms of size, we are 3 times the size of the nearest competition we have. And we are pretty much independent CAD agnostic environment, which in other words, like we can accept any kind of CAD formats standardly available in the market. So we are pretty much committed with the overall around 90% of customer satisfaction from our valued clients, and we are continuously driven to build an infrastructure and product offerings which helps the industry. This is a little bit about Fluid Codes. Fluid Codes is the elite channel partner of Ansys in the Middle East and Africa region. Now we started covering Europe as well. So basically, we are around this region since 1997. We have offices in UAE, Saudi Arabia, Bulgaria, and a couple of other locations to cater to Europe and Middle East Africa market. So basically, the elite channel partner is nothing but like we are at the apex of the channel partner hierarchy. In other words, like we are kind of official extension to Ansys to cater this part of the world. So we do have exclusive rights to distribute and provide support sales activities. We are more of a solution consultant than a off-the-shelf product sales people. So with the stronghold in this market since 1997, we have a team of engineers who are focused towards CAE related activities. So we do have a team with 15 plus experience within the Ansys environment, and also with the competitive environment as well, with PhDs and people from the premium institutes. We have like local training and development center, which is crucial for our valued clients for their training and support related activities. Having said that, like we are tightly connected and integrated with other ANSI centers across the globe. So there is a knowledge sharing session, which is two-way. They help us sometimes, and we help them sometimes. Overall, with a clear vision of helping our valued clients in the industry. So this is Middle East companies overview. These are to name a few. However, like our clientele is pretty much diversified. As you could see, we have clients from AEC sector, defense sector, manufacturing sector, EPC sector, NOC sector, IOC sectors, almost all of them. Also, as I said, like I would like to give you a brief overview on our new acquisitions, interesting acquisitions, who particularly helping us to drive to enhance our product portfolio. So these are, to name a few, Phoenix Integration as a company which is US based, founded in 1995. Basically, this particular company provides model-based engineering and model-based systems design software, which is pretty much used in almost all the verticals. Either it could be automotive, aerospace, or space for that matter. Ansys acquired this in 2021, which deepens our offerings, especially with respect to systems business unit through the model-based systems engineering. The next interesting acquisition would be Analytical Graphics Incorporated. So basically, if any of you are from space, then this particular company name must be familiar to you. AGA has a flagship product called STK. Basically, this STK product is being used by space and aerospace, particularly defense companies, for satellite trajectory related simulations, missiles, aircraft trajectory simulations, and also to define path in their particular applications. So this is by far one of the interesting acquisitions that Ansys has made in the recent past. And the next thing would be Ansys Limerical. Limerical is more a kind of dedicated photonic simulation tool, which helps researchers and engineering companies to come up with the new product development pertaining to the photonics component circuits and systems, which indeed strengthens our multi-physics portfolio, particularly with respect to the 5G, IoT, in general, Industry 4.0. So this is pretty much about ANSYS and fluid codes. If you need any more information, you can reach out to me through my contact information, as you can see on my slide. That's it from my side. Thank you very much for your patience.
Hello, my name is Rooh and I work at the Supercomputing Lab at KAUST. Today I will be talking about KSL services that are customized for the nation's engineering community, both academia and industry. We have recently launched a new consulting service. I'm very grateful to the organizers here at HPC Saudi for providing me with the opportunity to explain these services to the right audience. KSL has over a decade-old history of providing HPC services not only to the KAUST researchers and their collaborators, but also to the kingdom's researchers and students. KSL is committed to providing state-of-the-art supercomputing facility to our users. In addition to providing compute cycles, KSL offers other services like consulting, education and training, and community building. These services are particularly needed by the engineering community that usually starts their simulation career from their workstations. Our training and consulting program is intended to increase the use of HPC and AI services in the engineering community. We would like to reduce the barriers of HPC resources by easing the transition from the workstation to supercomputer, increase productivity, give a competitive edge to young Saudi engineers, which may translate into increased employability and train manpower for the Saudi industry. One of our major successes with an industrial partner was this record-breaking run on Shaheen II, which was a complicated multi-phase flow problem on a complex geometry. In this article, the engineer explains how a several weeks of work was converted to an overnight run. This is the power of HPC at full display. However, we are not only looking to engage in such high-profile collaborations. Our target audience includes students with a limited background in modeling and simulation and would like to learn it quickly to jumpstart their research. Researchers doing experimental work and would like to learn a convenient way to simulate the phenomenon he or she is investigating. Students graduating with a specialty in modeling and simulation and are interested in seeking employment opportunities. Saudi industrial partners looking to scale up their simulation on Shaheen or seeking advanced CFD services from KESA, and undergraduate students from Saudi universities interested in polishing their skills of modeling and getting exposure to a world-class supercomputer. Here is the structure of the overall outreach program. Our training program has two streams, namely modeling and simulation and artificial intelligence. We offer certification programs for Saudi students. We are in the process of finalizing a sandwich course that is designed to bridge the gap between engineering students and employers. Our newly launched consulting services consist of a helpline on which users can ask questions and seek help, as well as project-based consulting, which is targeted both for academia and the industry. The main challenge for launching such additional services is the lack of manpower at KSL or at any supercomputing center. It is difficult to justify additional headcounts for launching a new service. Therefore, we partnered with software vendors to establish training programs. This collaboration is mutually beneficial because our end goal is to increase user base and improve users' HPC experience. For the modeling and simulation stream of our training program, we are mainly collaborating with Ansys. Since 2017, we have conducted 8 workshops. We are offering these workshops twice a year. The next workshop is scheduled in October. Those of you who are in our mailing list and receive our announcements will soon be getting the invites for this upcoming workshop. Over 500 people attended our workshops so far. Due to COVID-19 restrictions, we are conducting our trainings online. While our trainees miss the in-person component with the trainers, we are able to accommodate more attendees online. Pre-COVID, in-person sessions were limited to around 50 people due to the availability of workstations in our conference rooms that were used for hands-on sessions. Now we virtually send the training material and instructions for installing software prior to the workshop. We plan to adopt a hybrid mode for our post-COVID workshops to better accommodate our attendees. That is, we will be doing physical training sessions while also broadcasting the training sessions online. So on the brighter side, COVID-19 did teach us few things. In addition to KAUST researchers, our attendees come from Saudi universities, the Saudi industry, and national organizations. Our online events are also attended by a sizable number of international participants. Here are the affiliations of the international and in-kingdom attendees. We can see that Saudi students attend in large numbers. There are also significant numbers of small and medium industries. During the registration process, we ask a few questions from the attendees to understand their needs and the roadblocks that are hindering them from accessing HPC resources. Most of our attendees are familiar with performing engineering simulations on their workstations, but they are not using Shaheen 2. However, they are interested in transitioning to a supercomputer. We conclude from this slide that our potential users are not finding it easy to transition their workloads from their workstations to a supercomputer. We try to ease this transition by providing numerous training sessions. However, first we have to motivate the potential users. What is the benefit for them? I normally give a sales pitch about someone rushing to meet a deadline. And in order to meet this deadline, he or she has to run the simulations much faster than they normally do on their workstations or smaller cluster. This example lets these potential users understand the idea of strong scalability. Looking at the numbers rather than the scalability curve is more impactful for a person who is not familiar with the concept of scalability. If they are not still convinced, I show them the power of HPC in an environment which is more familiar to them. Here you can see two simulations, one running on one node and the other running on 16 nodes. When the users see the difference in speeds, they get convinced, and now they are more likely to do the extra work to reap the benefit of HPC. Every workshop is slightly different from others, but the activities in a typical workshop include lectures on numerical methods and hands-on sessions on workstation and Shaheen. The students are given the basic ideas of partial differential equations and discretization methods. They learn about boundary and initial conditions, the difference between steady state and unsteady simulations, and implicit-explicit methods. They learn the difference between laminar, turbulent, multiphase, and multiphysics problems. The structural mechanics part of the training session covers truss, beam, linear elasticity, plasticity, and geometric nonlinearity concepts. Once the students understand basic PDE, initial and boundary condition, and the computational domain for the PDE, they are then exposed to the idea of coupled field problems and interface conditions. This short introduction might not provide them adequate theoretical and mathematical foundations, but this information is essential for them to select the right method and model from a simulation package for the problem at hand. The workflow of a simulation starts from the user's workstation. They first develop a model using design modeler or space claim. Then they make mesh in the computational domain and finally apply initial and boundary conditions and select material properties, numerical models, and solvers. Once the problem setup is complete, they are trained on running their model on Shaheen. Most of the trainees are not Linux experts, so we give them a lecture on basic Linux. Then they are exposed to the concept of a scheduler. Now they are ready to run their first test case on Shaheen. They are then taught how to change the number of MPI processes in their job scripts and perform strong scalability analysis. Finally, they learn to perform batch post-processing so that they do not have to copy data on their workstations for analysis. The next few slides will show various topics covered in the workshops and the types of problems the students were solving during the hands-on sessions. Here is an example of stress analysis of a pressure vessel, mathematics, mixing fluids at different temperatures, flow over NACA 0012 airfoil, vortex shedding as an example of an unsteady flow, a turbulent flow past a backward-facing step, a tank flushing as an example of multiphase flow using the volume of fluid method, HPC basics about scalability and profiling, a hands-on session on Shaheen. At the end of each workshop, we ask the participants to provide feedback on the workshop. Normally, they give us flattering comments, which are useful for us in establishing a business case for future events and even expand the program. As much as we appreciate the positive feedback, these compliments do not help us tailor future events to cater to our users' need. Hence, we add an additional feedback question in the survey to encourage them to give suggestions for areas that we can improve on. This is the suggestion log from our first workshop. During the 4 years, we were able to accommodate almost all of the requests. We have made all the tutorial materials and workshop recordings available on our website. Among the numerous AI techniques, deep learning is extremely popular as it falls right at the peak of the expectation curve, as shown here. AI has been applied to various fields, but there are limited examples in engineering applications. To apply deep learning techniques to engineering problems, one possible strategy is to convert the engineering problem into an image identification problem. We applied this strategy to predict superknock in IC engines. During numerical simulations, it is observed that varying the initial conditions causes markedly different converged solutions. Numerous DNS simulations were run with different initial conditions, and the images of the initial conditions were labeled according to the final solution states, namely no knock, mild knock, and super knock. We then applied VGG16 network on the training data and then predicted the final states from the images of the test data. We got perfect predictions of the final solution states by using the images of the initial conditions. Now that we have tested our strategy, we planned a training workshop aimed at engineers who are looking for an easy-to-use deep learning tool. The workshop was open to the kingdom's academia and industry, and MATLAB was the tool of choice. Once the users get trained on running deep learning test cases on workstations, a KSL scientist transitions these test cases on Shaheen and Ibex. Over 500 people registered within few days of the announcement. We had to shut down the registration process because we were exceeding the limits of our online tools. The training session consisted of 3 modules. First, introductory lectures were given, then the basics of deep learning was explained. Finally, 4 hands-on sessions were conducted on classification, images, transfer learning, and time series. Here is an example of applying transfer learning and retraining the last layer of AlexNet. This is an example of object detection in images and videos that could be applied in the field of autonomous vehicles. The majority of the participants were from Saudi universities and KAUST. Here are the affiliations of the non-KAUST attendees. According to the participants' feedback, the material covered had the right difficulty level for the audience. There is a strong interest in follow-up events. Almost half of the participants' deep learning problems are compute intensive, and there is a strong interest in distributed training on supercomputers. We plan to continue this workshop series in partnership with MathWorks. Based on the feedback of our workshop participants, we started a certification program for our Saudi students. Over the years, this certification program has become very popular among the students. Initially, we started off with a basic CFD and structural mechanics exam. Then we added more advanced certificates for returning students who have already obtained the basic training. We offered a multi-phase certificate in the last workshop. We will be offering a fluid structure interaction certificate in the upcoming workshop. In total, 188 students received certificates. Here you can see the diligent students taking the exam. Upon passing the exam, the students proudly receive their certificate and display it during a group photo. We are in the process of finalizing a computational mechanics sandwich course. The program will evolve in 3 phases: half-day lectures plus hands-on session on numerical methods, 1 week summer school, and a sandwich course for KAUST and external students. Finally, I want to talk briefly about our newly launched consulting program for the in-kingdom academia and industry. Data obtained from previous workshops suggest that the engineering community in the kingdom want to use simulation tools on Shaheen, but are facing barriers. They need modeling consultation, which is workstation-based pre-processing work, and they need help transitioning to Shaheen, that is full service on Shaheen. Before the launch of the consultancy program, the following services were already available to in-kingdom engineers: compute cycles, Ansys licenses, basic training and troubleshooting, and some advanced support which was limited due to a lack of manpower. Scientific consulting and human resources were missing. The goal of this consulting service is to support in-kingdom researchers kickstart their simulation-based projects on Shaheen. A fluid codes engineer is contracted for this service. A KSL scientist will work on transitioning the workflow from the workstation to Shaheen. Both the Saudi academia and industry can benefit from this service. KSL has engaged with numerous engineering software companies, but the choice of keeping Ansys as the main simulation tool was made based on the interest of the kingdom's engineering community. Here is the structure and functioning of the program, but you simply have to remember these links when you want to ask a question or apply for a project. Here is the information regarding our next workshop. The invites will be sent to those in our mailing list. If you are not in our mailing list, please send an email to the helpline and we will add you to it. Here is the recap of the services. Our training program has 2 streams, namely modeling and simulation and artificial intelligence. We offer certification programs for Saudi students, and we are in the process of finalizing a sandwich course. Our consulting services consist of a helpline and a project-based support. Thank you for listening. Now I'll be happy to answer any questions. Yeah, thank you very much. According to agenda, we have 6 minutes for question answers. If there are already some questions, some moderator can direct to me, or you guys can ask questions.
There are questions in chat box.
Okay, so I cannot see right now. If you can please read them
Yeah,
out for me.
Amir is asking, can expat engineer take admission for this training program and university provide evening classes or something like
So which training program specifically? Again, not. Let me. So any training. If you're talking about the training that we are having right now, yes, sure. This is, frankly speaking, this is mainly for KAUST and in Kingdom people. Since we have started doing online training, we allowed international people also to join. So.
Yeah, another concern was about suggestion to the topic in the next workshop, which obviously we can take care of. That was
Okay.
regarding turbulence modeling. Okay.
Oh yeah, that's a very good. This is really important suggestion. I mean, if you can, most of you, if you can provide this feedback, first of all, I will provide you the feedback form. You can put it there, and I think a turbulence model is indeed a very important topic that we can probably cover next time.
Yeah, Nikhil Priya has a question. Can we do molecular simulations in Ansys? I think Ajay can answer this.
Yes.
Yes. Okay. Is certificate exam only for Saudi students? Can faculty also take it?
Yeah, any Saudi in kingdom partner, researcher, industry, anyone can take it. So these are actually you are getting very close to some of the questions that I have already asked in the exam. So yeah, this is good. These are good questions. Yes, anybody. So let me repeat. Anyone in the kingdom can take certificate exam. Any industry in the kingdom can use KAUST licenses on Shaheen. Any person in kingdom can access Shaheen through a process. I'm gonna in the next lecture I'm gonna exactly show how to apply for Shaheen resources. So yes, sure, you can.
Yeah, these were the questions in the chat box. Anyone who have a question can unmute and ask a question now.
I'll be happy to answer.
Yeah, we'll wait for a minute. If there are no questions, we'll move forward with the next session.
Absolutely.
Yeah, could you please put the email which I need to email to be in the mail list? I think I will post it, right? It's HPC, right?
So so you can always contact us through CFD online at hpc.kaust.edu.sa. Now, if you were registered for this workshop, you are automatically added to the mailing list. But if you are attending this workshop because some of your friend gave you a link and you have not registered, then you need to register. The easiest would be to come to our website, and I mean, I'll after during the course of this workshop, I'll be sharing. If anyone of the organizer can share the website link in the chat box, then they can.
Yeah.
Okay, fantastic.
And Mansoor has a question. He's asking, are there no certificate of attendance for people taking outside kingdom? I didn't understand what.
There's no concept of a certificate of attendance, but if you take our certificate and pass, we will give you a certificate regardless where you are.
Good morning, Mr. Ulumin.
Good morning.
Mr. Ulumin, this is Asad Ali.
Okay.
I am from industry sector here in Saudi Arabia.
Okay.
I just went through this introductory lecture.
Okay.
So, what my question is, in the slides, Mr. Ajay he explained that we will be for the use of Shaheen supercomputers, we will be modeling our problem in the space claim, and then it will be subjected to meshing, and after for the results compilation we can go to Shaheen, right?
Uh, yeah. Go ahead. I'll
Yeah.
explain it.
My
Go ahead.
my question is, actually the most time taking activity in our problems is the meshing itself. So
Absolutely.
can we use this move to the supercomputers earlier? I mean, for the meshing part can be done by. I mean, for the space claim, okay,
I
our
got you.
workstation is okay.
I got you. I got your question. So
Thank you.
if you can mute yourself and then confirm if I have answered your question. This is a really fundamental question, and this ties in very nicely to my next presentation, in which I'm going to show you the complete workflow, starting from design modeler, geometry, meshing, problem setting, and then transitioning to Shaheen and post-processing. Ahmed is absolutely right. that the main computational bottleneck in the complete design process is actually the geometric modeling and meshing part. Unfortunately, that is a component that is that requires human intelligence, and thus AI is not going to take that job away from you. If we can speed it up, sure. I mean, if you look at the recent papers in meshing, there are very limited advancement in distributed meshing for general purpose geometry. If it's a simple geometry, you can do. Unless you cannot do distributed meshing, and what is distributed meshing? That is a topic of next lecture. Unless you cannot do that, there's very little you can gain from a supercomputer. However, Amir, what you can do is that, for example, some of our users are saying that, well, we have to make a mesh of, let's say, 100 million nodes, and then I need to copy that data to Shaheen, and that takes a lot of time. That type of work can be eased if you can take a coarse mesh and refine it through a journal file on Shaheen automatically through a batch command. And that is, I think, I'm pretty sure that is covered in today's topic. I guess Alessandro is going to talk about fluent meshing. That would be time for you to ask. If he doesn't cover it, you can ask him that how can we automatically refine the mesh so that you don't have to copy that data there. Very relevant question. I hope I answered the question, but some of these things will be covered in the next lectures. So I guess we have to now move on to our next lecture. So according to agenda, you guys are stuck with me for next 90 minutes. The good thing for me is that one of my colleagues bought me a coffee, so I'm all fresh. I'm not sure about you guys. So let me actually tell you.
If you have a minute, can you answer one question?
Absolutely, absolutely.
Yeah, Dr. Shamoon has a question. Doing refinement in cluster mode will not able the user to see what's going on in the boundary layer, for example.
I understand. So, Shamoon, these are the limitations of automatic meshing. I mean, I'm not saying that in a distributed way you can do meshing. Alessandro will be able to confirm it or correct me. All I'm saying is that most of the time we have to refine our mesh not because of geometry, but just because of the solution requirement. This is basically a uniform refinement, something like a doubling the mesh size type of thing. So that can be done, and over there you have already know that your boundary layer, when you will double it, you will get the y plus. So you have that intelligence. You're right. You will not be able to do it interactively, visually, but that's one solution. On the other hand, you are in a situation of visualizing and interactively making mesh, which is like a billion node mesh. I don't know how it's going to be done on workstation. So, I mean, there are pros and cons for both. Thanks for asking the question. Now, let's move on to the next 90 minutes. Folks, first, I'm going to tell you something about parallel computing basics. Now, that might be trivial for computer science people or people who are already expert, but I'm assuming you guys are CFD person and have very little background in parallel computing. So then from parallel computing basics, I'm going to move on to high performance computing, and I will tell what Shaheen can offer you. Amir was right in saying is that meshing is the main bottleneck. But I would say that, well, if you have to converge a solution, very, very complicated DNS solution, computation itself is a bottleneck also. That luckily can be minimized by using parallel computing. Then we will have a complete hands-on session from workstation to Shaheen. I mean, I will just take a very, very simple 3D cavity problem. We'll make the geometry, mesh it, apply the boundary condition. I will show you how to connect a Windows workstation to Shaheen through some GUI, and then I'm going to take you to Shaheen and run something. Some of you might have access to Shaheen, some of you might not. I urge you just follow the steps. You have all the material, you'll be able to follow it later. And the last, I have a bit more complex hands-on session for a flow over a sedan car. So if this sounds exciting, so let's get started. So now, all right, folks, again, caveat. This is really a beginning material. There's a full workshop on this, and in fact I got this material from a 16th LCI workshop at a time when I was at NCSA in US. It's a very basic summary of what was covered over there, and these are the references. All this material is already shared with you guys. All right. Fishing. We all like fishing. The idea of parallelism is that, well, if we can put more workers to a task, then we can either finish the task faster or we get more work done. Very simple idea, fishing. We all understand this thing. But in parallel computing world, these fishers are actually processors. So parallelism is the use of multiple processors to solve a problem. Okay. You must have heard about these three paradigms: shared memory, multi-threading; distributed memory, multiprocessing; and hybrid shared distributed parallelism, meaning combining shared memory and distributed memory. Let's go a little bit deeper into that. So threads execution sequence that share a single memory area address, which is address space. So threads are mainly for shared memory type of parallelism. Processes execution sequences with their own independent private memory areas. So you have independent private data when you are doing process parallelism. A general rule is that shared memory parallelism is concerned with threads and distributed parallelism is concerned with processes. In principle, again, shared memory parallelism is multi-threading, distributed parallelism is multiprocessing. I'm going to go into more detail what it actually means. So these are just the terminologies that you might want to know that. And towards the end of this lecture, I'm going to tell you why I'm actually trying to teach you this thing. If you just want to run Fluent on Shine, or if you just want to use Ansys HFSS, why you want to know about these things. We'll get some connection later. Okay, what is a serial computing? So suppose you want to do a puzzle, a 1,000-piece puzzle. Sure, I mean, if we have nothing else to do, we can do it. And let's say we can do it, one person can do it in 1 hour. I cannot do it in 1 hour, but maybe some smart person can do it in 1 hour. What about if he asks some of his friend, supposedly Tim in this case, to work with him? So both of them, they can work, and then probably they can do it a bit more efficiently. However, in some instances, they will start competing for the work. So there will be some pieces in which both of them, they would want to take that work. So that's the contention, the work contention. And then they have to communicate among each other to say, okay, let's assign this work to you or me. So there's a little bit of overhead on the pieces where there will be a contention. And that's why two people can not do that work in 30 minutes, but probably in 35 minutes. Let's add more people. Okay, more people. If more people in principle can get it done more efficiently, but the contention will increase actually as you are increasing the efficiency of working on your own piece, but in the contentious pieces, you're losing the efficiency. So you will not be able to finish this puzzle in 15 minutes. Ideally, probably you will finish it in 20 minutes. Now you start adding more people, and then very quickly you'll start seeing diminishing returns. Means that you keep on adding these workers, but they at some point they'll be just fighting among each other. I'll do it, I'll do it, I'll do it. So there is a diminishing return in this framework. Now let's think about some another way of solving the same puzzle problem. Let's say we put these puzzles onto the same 1,000-piece puzzle on 2 tables and 2 people start working on them. That's good. Each person has their own private data and then they can work on that, right? But they will have to communicate at some point because each one will be missing some of the data, and then when they have to get that data, they will have to communicate with the other person. So there is a concept of communication coming, right? So interprocessor communication coming, and then there is a concept of decomposing the problem. In the beginning, in during the meshing part, we discussed that first we have to mesh and then we have to decompose that mesh, right? So that decomposition problem is now emerging because of the distributed parallelism. We can happily add more people here, but again, as we increase the number of processors, it's good. The data that they have locally, they can very fast, quickly work on that. But with adding more partitioning or decomposition, we are adding the communication cost, and we are making the load balance a bit more complicated problem. So we have to now divide the puzzle into 4 pieces. So the concept of load balancing is that giving everyone roughly the same amount of work to do. So that is, if you guys are familiar in numerical math, that's something like a graph-based partitioning techniques like Mattis or Chaco type of thing. So we use, Fluent also uses these parameters tools to partition the meshes. Some load balancings are trivial, as you can see on the picture on the left, but some are difficult, as you see in the picture on the right. So you can think of a structured mesh or unstructured mesh. Structured mesh, it's trivial to partition them, but on an unstructured mesh, it's a NP incomplete problem. So you can only approximately divide it into equal parts. For those of you who have never heard, by the way, I have not said the word OpenMP and MPI, but that's a programming model. So MPI is a distributed way of doing things, and OpenMP is a task-based, thread-based parallelism. If you want to understand MPI way of doing thing or distributed multiprocessing, and this is the first time that you are exposed to this idea. So just imagine you are on a vacation, paid vacation. Let's make it sweet. Paid vacation on an island, and you have a nice hut to you. There's a desk on that in that hut, and you have a phone, you have a pencil, you have a calculator, you have some numbers, and you have some instructions. So you are fine, you are independent, you are happily working in your hut. You have all the data to you, you can complete your instruction. However, if you have to do something, if you need some data from other part, you have a telephone number and you can call. So all these translate into computer terminologies. So the data is private to the processor, and then the processor can communicate just like that guy was communicating through phone. These processors can communicate through message passing, which is MPI way of doing things. The cost of passing a message is split into latency, which is a time, a connection. You can think of it as connection time, and the bandwidth, that how good your connection is. Okay, now I have to move on to the next slide, but while I'm transitioning, you think about it, how these 19 slides were relevant to you. So they are relevant to you if you are just a user of Ansys on a supercomputer, because you need to know that any binary that you are given, any executable, any code that is given to you, can it benefit from distributed memory or not? You need to ask yourself, or you need to search that, let's say Ansys HFS, is it OpenMP code or it's an MPI code? If you have an OpenMP code and you want to run it on 200,000 cores of Shaheen, it's not going to help you. Fluent is a distributed memory code, so it can run very efficiently. So these are the things that you might need to know. If there are questions on this part, I'll be happy to answer, but I'll take a minute to transition to the next slide. You have some idea about MPI way of doing thing, OpenMP way of doing thing, which was a thread-based parallelism and the process-based parallelism. Now I want to tell you what Shaheen can offer. First of all, how you can access Shaheen. So that was, I mean, the essence of many questions that we received. So let me explicitly tell you how you're going to access Shaheen. So basically, if you want to do a very, very fantastic scientific project based on Ansys, what do you need actually? What resources you need? You need computational time on Shaheen, right? You need license, Ansys or Fluent licenses. You need some support. Maybe you are not familiar with supercomputer environment. Maybe you are not familiar with Ansys, so you need some support. Or you need some consulting that, well, I have this idea. For example, the best case scenario would be you are an experimentalist and you want to reproduce your experiment in a numerical world, and then you have not much experience with modeling and simulation, and you don't have any idea about doing HPC. So you need all these resources. First of all, the computational resource allocation. So how you're going to get the allocation on Shaheen. I'm not going to go into the detail of this thing. All I'm going to tell you is that it's a project-based allocation. If you guys have any exposure to any HPC center in the world, that's how it is done. So you basically apply for a project. You have a very interesting idea. You want to do a multi-phase problem, fluid structure interaction problem on a really cool application that is never done before. And then you just apply, you write a proposal, and then it goes through a review process, and it gets approved if it has merit. This might sound too difficult for you, and I understand it is difficult. So that's why I mean, you just contact us and we are going to help you. I'll give you the emails. So this is something that you guys, you might get in exam papers. You really need to know these things, okay? All Saudi academic institutes with Ansys license can use Ansys license on Shaheen. There are 11,000 core licenses. You might know that Ansys is a core-based licensing system. So we have acquired 11,000 core license. So you can really scale your problem on Shaheen using our licenses. And all academic institutes which has Ansys license, just one license, they can use our license. So for example, KFUPM folks, KU folks, just check with your admins. If you have Ansys license, I can tell you that you guys have licenses. So you can use these licenses on Shaheen, our licenses. I will happily share it with you. All Saudi industry partners can use KAUST Ansys license on Shaheen. I mean, Aramco, Sabex, everyone, you guys can use our licenses on Shaheen. The only caveat is that it has to be an open research. You cannot do a closed research. So if you can publish that work, happily you can use our licenses on Shaheen. All you need is a good application that is suitable for Shaheen. I mean, you need to come up with a nice application with based on which we can create a project for that. So basically the message is take benefit of a scalable code. Fluid is extremely scalable code on Shaheen and a scalable supercomputer to solve your real life problems. All you need is a very, very nice engineering problem. I must say it might be too much. What I mentioned is too difficult. You don't have to worry about anything. You just send email to this link, cfdhelpline@hpc.kaust.edu.sa. Just ask, how can I run Ansys on Shaheen? I need consulting help from you guys. So we'll just follow up. I'll just follow up with you guys, and then we'll take care of the paperwork. Okay, let's see. You guys must be saying, okay, I'm saying too many things about Fluent on Shaheen, and but again, what is there to do? Again, now you have learned a little bit of parallel processing ideas. So I'm going to go a bit more deeper here in just one slide. It's a little heavy slide, but this is important for you to understand that what to expect from a scalable code and a scalable machine, and whether your machine is a scalable or not, or whether your code is scalable or not, you need to understand. And even if your code is scalable, whether your workflow is scalable or not. Okay, so this talks about this called about a little bit about the profile of a parallel code. What is a profile? Profile means that in which component your code is expending the time, meaning that either it is doing a lot of computations, matrix algebra, or lot of communication, lot of message passing, or lot of IO, meaning that lot of reading and writing. Only certain part of the execution can benefit from parallelism. So that could be one of the questions for you guys in the exam. If your code is doing a lot of IO, lot of reading and writing of file, and not much computation, will it benefit from Shaheen? Well, the answer is no. If your code is doing a lot of computation and very little communication and very little reading and writing of the files, then it can benefit from Shaheen. Okay. The concept of parallel speedup. The speedup of a parallel algorithm over corresponding sequential algorithm, meaning that if you run your code, let's say if you run cavity problem on one core of Shaheen, it finishes in 1 hour, and then you run it on 1000 cores on Shaheen. In principle, if everything is fine, if ideal setting, it should finish the computation in 1 hour, 1000 of the time that it took on one core. All right, and now you guys know these things. So parallelization techniques, you know about MPI a little bit. You know about MPI, you know about OpenMP, and then there's a hybrid way of doing things. You combine MPI and OpenMP benefits. You also know a little bit about domain decomposition. I think we called it a partitioning problem, a load balancing problem. But in the computational mechanics world, we call it domain decomposition, which is nothing but partitioning your computational mesh. Once you make your mesh, then you have to partition into as many processes that you are going to run on Shaheen. So dividing, again, none of it you have to do it. Fluent is going to take care of all of this thing, but you need to understand these things. So it is basically dividing spatial problem into smaller parts. Each sub-problem is solved on a separate processor, as I've shown in the previous slides. And then each processor will start communicating at the domain boundaries. And you need to also know that what is the concept of spatial and temporal parallelization, meaning that in this, you have seen yourself that you are basically only partitioning a spatial problem, spatial computational mesh. So you can only benefit from parallelization in space. In time, you can still have to do that many number of times. So you can only speed up spatial problem. Temporal, if you have to do your DNS simulation for 1 million time step, you just have to do all over again for 1 million time step, right? That's a fundamental problem of semi-discrete formulation that we use in fluid mechanics. There's very little that you can do in time domain. Okay, so I ran this 140 million node mesh on Shaheen using 1000 cores, and then when I increase it to 4000 cores, I almost got 3.5 times speed up, which is really good. So you really want to reduce your 24-hour simulations to 6 hours. That's really a time saver, right? So seeing is believing. So let's say this is the same problem I'm running on top using one node of Shaheen, and below I'm using 16 nodes. Those of you who are computational people, you have seen these plots on your workstation or your supercomputers, and they're really annoying. I mean, the top window is really annoying. I mean, come on, 15 iterations, and you are always to 250 iterations with 16 nodes. So I think you get the point. It is there is one thing to talk theoretical, but seeing is believing. So you have seen with your own eyes that parallelization really is effective if you use Fluent on Shaheen or any other nicely scalable supercomputer. Okay, so that's how typically in the papers, if you have seen some even in computational mechanics paper, you guys these days expect to have some parallel scalability results. So you put log scales, and as shown in the top right corner. So that's how you report your results. All right, while I transition to the next slide, I'll be happy to take any questions.
Yes, Rooh, there are some questions. Dr. Shamoon has a question.
Yes.
What is the advantage of using hyperthreading in shared distribution?
A very good question. If your code is hyper-threaded enabled, you can use. So on Shaheen, let's say there are 32 physical cores and there are 64 hyperthreads. If your code is hyperthread enabled and your task have very little contention, you can benefit from that. However, with a caveat, with Fluent, we always disable hyperthreading on Shaheen. I have seen very little examples in which hyperthreading was effective. Most of the time, Shamoon, the explicit algorithms, I don't know, in CFD we use explicit method, but again, if it's a impact analysis or something like a spectral earthquake seismic analysis, for example, or reverse time migration type of things, over there we have seen that hyperthreading was effective. That's one component. The other component is that you might want to say that what is the benefit of hybrid parallelization? The issue is that the modern architectures have so many physical cores. Forget about hyper threads, physical cores, that it is becoming very difficult to extract the full benefit even from one node. So you might not want to use that many MPI tasks. For example, the modern architectures are going toward 120 cores or even more per node. So you might not want to use 120 MPI tasks per node. You might want to use let's say 60, and then each process enabling 2 threads. That might be more effective. Up to Shaheen 32 cores, I use 1 MPI process per core, and that's efficient for us. Having said that, the code needs to be multi-threaded. So not every code is multi-threaded. I hope I answered the question. Any other question?
Yeah, Kareem Khalil has a question. So as a Saudi industry, we have access to Shaheen, or we need to send you the model and you run it on Shaheen?
I'm so happy that we are having all these questions. Both are possible. I forgot the name. Khalil or
Kareem Khalil.
Kareem. If you don't, let's put the in-kingdom consultancy project on the side. The standard way of doing things before was that you guys write a proposal and it goes through a review process, and then once you get allocation, we give you access, and then you go ahead and try this problem. So that was the old way of doing things. It is still the way to do. But we noticed that sometimes you don't want to wait. You first need some preliminary results. So that's why we designed this in-kingdom project. In this way, I have already opened an account for Saudi industries and academic partners, and then you just send me your data, and then there is a little bit of paperwork. We'll work it on it together. But to answer your question, I'll run it and I'll give you the expected results. Initially, the main investigation happens that, well, is Shaheen suitable for my workflow or not? And then does it scale or not? So that type of work we have already done. I think Ajay and I, we already started working on numerous projects with, and Philip is also working on that. Yes. So first of all, Kareem, you send email on CFD helpline, and then we'll get started. And for all wider audience, if you are in Kingdom researcher and you want to start a project, and you do not want to go through the pain of doing it yourself on Shine, we can help you. You just make your models on your workstation, send it to us, and then we can run it for you.
Yeah, there is another question, Mr. Hamid Majid. He says if he understands this correctly, Ansys only uses MPI.
Oh, that's a very good question, and that is a question for you guys. But let me take a bite at it first. I'm sorry, I forgot the name.
Yeah,
Hamid?
he's Hamid. Yeah, Hamid.
Hamid, I did some scalability runs using Fluent. I mean, when you say Ansys, Ansys is a very broad. There are many components there. But I'm going to just talk about Fluent because I'm familiar with that. So my understanding was that it was not threaded back then. It is 2 or 3 years ago. I will be very surprised that if the developers have not already done it or they are trying to do. That must be in the future roadmap because, as I mentioned, the new architectures are not going to be very efficient for purely MPI code. My understanding is that Fluent is pure MPI. Till now, most of our users are using one MPI process for one core. That's how we're doing it. If any one of the Ansys folks have more information, they can correct me.
Yeah, I'll ask Ajay to answer that in depth,
Okay.
clearly once he's back because he has an issue in his computer now.
No worries. No
So,
worries.
yeah,
No worries.
we have another question to answer here.
Yes.
Yeah, this question we answered. What is the advantage that I am new to? This is from Ibrahim Mustafa. He says he's new to parallel computing. Just a simple question: how we decompose a sequential problem?
Oh, sequential problem. You don't need to. I mean, okay. Let me say it in this way. If you want to convert your sequential problem into a parallel problem, if that is the question, then you partition your problem. It's difficult to. Okay, I have to give you a very general answer. You partition your problem. If it's a mesh-based problem, you partition your mesh, and then use each partition will be solved in different processor. Think of only two processors to make it simple. So you have, let's say you have 1D problem and you partition, let's say 100 nodes into two parts, and then you have to communicate the data at the 50 or 51st node, right? And that is where you will be communicating. In order to understand it fully, you need to go through some basic MPI. If you are a developer, sure, that is the way to go again, and you can contact me and I can give you some more material, or we can have some simple hands-on session. But if you are just a user of Fluent, let's say, or some parallel code, you don't have to do a decomposition yourself. Codes will do it for you. I hope this answers your question. Any other question?
Yes, Rooh, we have a question here. Yeah, similar one. So as a Saudi, we answered that already, right? Another question would be, if I have no background in Fluent, can I still cope with this training? My experience is only with Ansys Mechanics. Kareem has this question.
Oh, Kareem, this is exactly what I'm going to show you in the next 30 minutes or so. So what I'm going to do, I mean, I'm really happy that because I designed it for beginner. So what I'm going to do is that I'll make a very simple 3D cavity problem, just line by line, because I agree with you. It's not really easy to get started on this, but even if you go through these online YouTube tutorials, Fluent has so many icons, it gets very confusing sometimes. Even in today's session, you will see that, well, maybe sometime you will not be able to follow my screen fully, but I get your point. So yes, absolutely, you'll be able to benefit from that. So can I get started or we have more questions?
Yeah, we can get started, Roo.
Okay.
On this, yeah.
So can you see my screen? No. Why you cannot see my screen? Okay, because I have not shared it. Okay. Now you can see my screen?
Yes, Roo, yeah.
Yes. Okay. So I think we have a bit 40 minutes or 50 minutes more. So what I'm gonna do is really a very, very simple. I mean, those of you who are expert, well, you might not learn much except how to transition to Shaheen, but who are beginners or who are experimentalists, and like Kareem, if you are a mechanical person, structural mechanics people, and you want to do some fluid problem, and then with the hope that you want to do some fluid structure interaction problem, this would be a nice tutorial for you. So first of all, you need to install Ansys on your workstation. And that itself is a challenge because I receive so many questions from you guys. Well, I am using Mac. And in fact, you can see I'm also using Mac in front of you. So how do I do that? Well, you cannot. So these are technological problems. These are things that make things not easy for people, but we have to overcome these issues, right? So it's advisable to use Windows for interactive session for Ansys, and then take your case file to Shaheen and run it on Shaheen. Either visualize it over there by batch post-processing, or bring your solution back to your workstation and use either Ansys post-processing or TechPlot or Paravi or whatever you want to do. So that is something that we are going to cover. So I assume that you have installed your Ansys on your Windows machine. This tutorial was done on Windows machine. So first you're going to go and do the run WB2 command, and Ansys module will show up. So it's loading up right now. I must confess that sometimes the icons might be very slow. I've shared these videos with you guys. It might be useful for you if you play video again. So now I'm open at the geometry module. So you can see below that, well, design modeler is opening up. So sometimes it gets a little confusing that, well, something is opening or not. So I select my XY plane. So you might not see that fonts are small. I'm going to say I'm making a rectangle on the XY plane. Then I'm going to select the dimensions. I'm going to make it a by unit square. I'll select the height and width of the rectangle, 1 meter each. Now I'm going to zoom it so that I can see it properly. Now I would want to extrude this thing, extrude this in by 1 meter to make it a 3D box. So now we have a 3D box. Now I have a one part, one body in here. So what else we have to do? We have to identify the surfaces. The top surface is a sliding surface. It's a different surface where you have a velocity specified. I name it as, that's a moving wall. All right. So now I have a challenge of naming the, oh, sorry, what happened here? Oh, sorry. So now I have to restart it. Sorry. So now I will define the next 5 surfaces. They're all no slip, so it's a bit complicated to select all these faces. You need to use a control mouse and the center mouse to rotate these things, and then the bottom also, and then you name it like a stationary wall or so I'm naming it as stationary wall. All right, so we are done with defining the two different type of boundaries. Then we need to do a very important part where we have to define, well, we are solving which type of partial differential equation we are solving. So we have to define this volume as a fluid volume, not as a solid, because we want to solve Navier-Stokes equation on it. So once we define this fluid part, then we tell fluid that, oh, hey, you want to run Navier-Stokes on it, not a stress analysis problem. So now we have all the faces correctly defined, and now what we want to save this mesh file. So I would want to export this thing in the folder that I have. Call it cavity, and I saved it. Now I'm going to close the design modeler. Then I'll go into the main menu. I can see geometry is checked. So now I'm going to open the mesh module.
Rooh, sorry to interrupt.
Yes.
There are concerns that the options you are selecting are not clearly visible.
I agree, and unfortunately, there is pretty much nothing I can do. The only other option would be, because my screen was very big, and when that's how it is. I have shared the videos with you, and you can play the videos, and then you can probably zoom it like that. But I'm gonna keep on telling you guys on the way what I'm doing. That's all I can do right now. So meshing is started. So we made the geometry of the cube. Now we are going to open the meshing module. So it's just loading. So I have geometry, material, and mesh icons there. I agree. This might be difficult to follow. In the next presentation, I'll do something differently. So I'm selecting the element size at 0.01. This might be a quiz question for you folks. Be careful. So I selected 0.01 as a mesh size here, and the mesh is being generated here. The mesh size has consequence on the Reynolds number. Mesh size has a consequence on the limitation of which type of Reynolds number you can solve, and the stability of the problem and convergence. So you guys need to be familiar. You need to know that how fine mesh for a given Reynolds number you might want to do. For now, I just use a 0.01 mesh size. I'm all set here. I just meshed it, and then I'm going to save this mesh file. While I'm saving the mesh file, I must tell you that the Shaheen part would be, I'm going to do it in a much bigger font. So that to me is a bit more useful for you guys. So you'll be able to follow everything over there. So I'm saving this mesh file. I'll call it cavity. Cavity mesh, cavity underscore mesh, I'll call it. And so it's saved. I'm going to get out of the meshing module. So you have defined your computational domain, you made the mesh, and now we are going to set up the problem. So you might notice that, well, there is no partitioning, no matters we have to do. Ansys is Fluent is gonna do it for us. So I have selected a double precision, 3D double precision version of Fluent. So here you will have to do quite a few things. First, let's wait for it to load properly. And now I'm gonna open the so I have to first open the mesh file. I'm importing the mesh. There's an error, I think, with some Fluent expert. I might need to know what this warning is actually. I'm opening that cavity_mesh file that we just created. I'm waiting for it to be loaded. It tells some information about the mesh. Still loading. Now it is loaded. Now we can see our model with the mesh. So in the options, I have turned off multi-phase. I have turned on turbulence. So we are using two equation turbulence model here. In the cell zone, I can confirm that I have fluid, because that's important. Meaning that, well, we are solving a fluid problem here, and I have selected air. That's also important for your quiz maybe. So we are selecting air here. So now the most important part is the setting up the bounding conditions. So I'm going into the moving wall, and I'm defining it as a moving wall, and I set a velocity of 1. It might be too much actually, but well, let's do it in this way. So 1 meter per second velocity I set, and on a stationary wall I do nothing because it's no slip stationary wall. Next step would be I can go into the methods. I don't change anything here, and solution parameters I don't change, but I do need to initialize our problem. So I use hybrid initialization. There are two ways of doing initialization, standard and hybrid. So I just clicked hybrid initialization. Now I am all set to run my simulation. I am selecting number of iterations, maybe 100, or maybe I'll just do 10 iterations here. I'll run it, and it will start running now. Now we are all set. If all the things are fine, it will start running. And the important thing is that it automatically writes your case file, CAS file. This is the file that you really need. So this is the file that you will take from your workstation to Shaheen, and then you will start working. Now I will close this window because it has started computing, and it's extremely slow. I mean, that's one point that you might want. It's a simple 1 million node cavity problem, and it is really slow. I mean, it has not even done one iteration. So I'm gonna close this thing, and I'm gonna open another window for you, in which I will tell you important thing about how to connect your Windows machine with a supercomputer. Because since if you are a Windows person, you might not have even heard anything about a terminal, the black thing, or if you're not very old, you might not even have done it in Windows. DOS, that was early 90s actually. So you need to install something on your Windows machine. So you can go to our website, hpc.kaust.edu.sa/windows, and then you have to install a tool called git bash. From here, all the instructions are here. I'm going to show it to you because we receive a lot of questions like that. how to do that. So let me just show it to you. It will just going to take a couple of minutes, but well, let me show it to you. So while it is downloading, let me tell you. So you communicate to a supercomputer through terminal. Yeah, I mean, there are some other tools like PuTTY, other tools, but in general on Linux or Mac, or even in the way that I'm doing it on Windows, you communicate it through a command line. I'm going to show you all the steps here. Okay, so if everything is done correctly, I will have an icon of git bash on my computer, and then it's still being, no, I don't need to close it. It's still being installed. I have a git bash icon here, and now I launch git bash from wherever it was installed, and then you will see this rather ugly looking black window. So you might say, well, all of that effort just for this. So I must tell you that the fonts are very small, but in a couple of minutes, I'm going to show you a very big font. I will repeat all these steps. So basically, I just want to show that by installing this tool, you can connect to Shaheen. So I'm doing SSH to my user account, shaheen.hpc.kaust.edu.sa. If I do this thing, it will ask me to put my password. I put my password here. And then there is another password that is needed.
Maybe Roo, you can maximize this window. So
yes, I'm coming, Ajay. This is just I'm done with this thing actually. So I'm gonna make it very big now. All I want, because I'm gonna transition now to Windows. So I'm going to transition to my Mac actually. That's my preferred tool. But all I wanted to tell you guys is that you can connect your Windows machine to Shaheen, right? Okay, let me now make it really big, and you're gonna see everything what I'm gonna do. That's better.
Yes.
Right? Okay. Before I do this thing, let me share with you guys so these are the files that we made with the session. So this is the cavity underscore mesh.case file that we just generated during our session. What I'm going to do next is I'm going to copy this file to Shaheen, and I hope that you can see. I can even make it a bit more bigger, the fonts. So you guys, some of you are Shaheen users. You can do this tutorial using your Shaheen credentials. Some of you received instructions from me regarding your username and your password. Please don't share it with anyone. And now you can use them to run this tutorial with me. So those of you who do not have a Shaheen account, well, you guys need to actually set up a new permanent Shaheen account with us, because I explained you everything, how to set it up, a permanent account, and so that you can start doing all these tutorials yourself. All right, so first of all, I need to copy the data. So I'm going to copy. This is the command for copy. scp-r, the path of the file on my desktop. On my desktop, I have 3D cavity, and then in here I have this file. I'm copying this file to my username and on Shaheen. So you guys have received your username. You just change your username this to your username. It's like something like KSL training, and there's a number over there. I'm gonna not tell you exactly. All right. If you do this thing, it's gonna copy this file to this location on Shaheen. So let's do this thing. It copied the data. I put my password here. For you, it's not going to ask for the second password, but for me, I have to put the second password also. And it started copying. And that was the bottleneck. That is where you needed to. Now I log into Shaheen so that I can start working on this problem. Again, the password. So folks, I am on Shaheen right now. This is the file that I just copied from Shaheen. Okay, so now is the time you really need to understand a few things. You need one case file that you just created right now. You need a job script on Shaheen to run your job. So what is a job script? Let me tell you. And before that job script, you also need a journal file or input file of Fluent to run this job. So on your workstation, you just press that run button or run the solver, and it starts running for you. On Shaheen, you do not run it in an interactive way. You do it in a batch mode through command prompt. So this is the file that something like this you will be needing. I'll show it to you. There's nothing. This is, let me clear so that it's more clear for you. There's nothing. It's just say that, well, read this file, so run it for 1000 iteration, use a parallel timer, and then write the solution. This is the solution file, and then exit. That's all there is to the journal file. This is the instruction that is given to Fluent so that it starts running. The second file I told you, I'll repeat it actually, because this is the only important part actually. Otherwise, you just run few commands and it's going to start running. The second important file is a job script. So this is the job script. You don't worry about these things. So you, in the training material, you have all of these things. So you're running with 8 nodes. Let's not run it with 8 nodes for now. Let's run it on with let's run it with 1 node. On each node of Shaheen, you have (32) cores. You change this T32 and one node. Then you load a module Ansys. What it means? It means that you don't have to install Ansys on Shine. It is already installed for you. You just load this module and you're all good to go. And then this is an executable command for Fluent. That's it. Now we are all set to run. So those of you who are using training accounts, you're gonna run it like this. You have to use minus reservation is equal to Ansys command. Then you will be able to run it faster. I'm just gonna run it. Let's see if it is running or not. If in order to check the status of the job, you do sq minus u and your username. You'll get the status of your job. Your job is running. Let me make it even more bigger. Okay. So now there is an output file that is being generated. Which is something familiar to you guys. So it's running, it's setting up some connections, and then it's reading the input file. You can see that the job is running, but I'm not 100% sure if it is running correctly until it starts doing the iterations. So it did something like a reverse Cuttle-Mackey condition to minimize the bandwidth of the matrix. Nothing we are doing. Fluent has all the intelligence to do that. So now the iteration starts. So it's you can notice that it's a little bit faster than what we observed on the workstation. So but still it's just one node simulation, right? What will happen if I use 4 nodes? So remember, you need to use the number of nodes. I'm using 4 nodes. And then how many MPI processes? 4 into 32. No, not 129, it's 128, right? So let's run it. Let's see how it goes. I check the status of my job. The job is running. And I look at the output file. So it's setting up the connection to 4 nodes. It automatically sets the processor infinity, which is just a HPC terminology. But again, I just want to show you something. And then again, this is all the sequential component that it has to do. Again, it did the matrix compression, partitioning. Again, we did the load balancing part. So now it partitioned this mesh into 128 parts. So now you can see it's really running very faster. I mean, I understand it might be a little heavy material for you, but the point was that you really get the return for your bank, and then you get some parallel performance and time to solution information over there. Again, you can keep on increasing the number of processors, you keep on getting reduction of time to solution. It is not actually one-way street. You cannot keep on increasing the number of nodes and keep expecting that the time to solution will decrease. So this is the idea of parallelization concept, the contention and communication cost that I try to explain it to you. You cannot indefinitely increase the number of processors. The idea is to get the right amount of processors for the given problem. If you know this thing, then you will be able to get the optimal core count for your problem. I think that's all for this tutorial. In the next tutorial, I'm gonna solve a more complicated problem of a flow over a sedan car. And in that tutorial, I have explicit commands for those people who are not Linux users. I'll go much more slowly. In this tutorial, I just wanted to show you how to prepare a cavity problem on your workstation on Windows, connect it through that git bash, copy the data to Shaheen, have some journal file, just a scripting file, and the job script, and run it on Shaheen, change the number of processors to see if it speed up the calculation or not. So it might be heavy, but believe me, you have gone through the entire process actually. Now the only thing that is missing is that now you have this solution file here. You have this solution file, and now you can go ahead and visualize it. Before I go on the next tutorial, I want to show you one thing, which is again one part of the tutorial that you guys have to probably do. Let's again, this was just the cosmetic things. There's nothing engineering that you learn right now, but let's talk about a little bit of engineering. And our end goal is to converge the solution, right? So yeah, it's reasonably converged solution. Here is what I would want you to do actually. When you're making your cavity problem, change the sliding wall velocity from 1 to 0.001, and then see what is the effect on the convergence. So so that's something that you might want to investigate, because that investigation will take you to the concept of, okay, what are the stability limitations, why my simulation is not converging, do I need to refine the mesh, and all those type of things. So I'm gonna take a couple of minute pause for your question and answers. I admit some of the slides might not be visible, but you do have all the recordings in the original form, so you can zoom and follow everything. And I also know that not all of you have the Shaheen account, but for that, well, we share responsibility, folks. We are doing it for 4 years. You guys need to be Shaheen users by now. So work with me and become permanent Shaheen users so that you can use all these tutorials yourself. I'm transitioning to the next slide deck, and then in the meantime, I can answer any of your questions.
Yeah, Rooh, Muhammad Ali has a question. He
Yes.
says, can he make mesh importing file from CAD? I think he's asking for other third-party CAD, any third-party CAD.
In principle, yes. There are a lot of interfaces. Again, the best person to answer those questions, those would be, I think Alessandro is going to take you into the fluent meshing. and probably you can ask Ajay also, and they can go deeper into what type of CAD compatibilities there are in Fluent and Design Modeler.
Yeah, Hamid has a question. In continuation to what you have mentioned, how do we know what are the optimum number of processors for a Fluent problem?
Oh, I think we covered it. So what I did, Hamid, was that we had 1 million node problem again, and then there were, I believe, 5 degrees of freedom plus 2 turbulence degrees of freedom, 7 degrees of freedom. That's the size of this problem. I first solved it using one node which had 32 cores. It gave me a time to solution, and then I increased the core count to 128, and then I would compare it with the speed up, expected speed up. So it will not speed up ideally, but it's up to us. I mean, if increasing the core count is reducing the time to solution, am I willing to keep on increasing the core count, or I'm fine? So all of that is based on your expectation, but at some point it will definitely stop scaling actually. So if you put a million cores to it, it will not give you 1/millionth time to solution. That is the discussion on the Amdahl's law, which I did not do. But again, that is a discussion that you guys can Google Amdahl's law, and you can understand that there is always a sequential bottleneck that will affect the parallel scalability of any general purpose code.
Rooh, can I jump in here and
Absolutely.
Yeah,
sure.
So the question regarding how many processor we should use for a given Fluent problem, the practical or thumb rule you can apply is like, if you have a 1 million cell count, you should use at least minimum 4 processor, you know. So accordingly, you can utilize this thumb rule, and you can get a better scalability on the parallel side. Thank you.
Oh, that's a very nice thumb rule.
Yeah, Ajay, sorry, Rooh, we have another question from Ibrahim Mustafa. Can we graphically analyze our simulation results on Shaheen as a remote user?
Okay, so yeah, that is a very good question. That is going to be covered in the next hands-on session. I'll show you how to do that.
Okay.
There are some caveats on that. There are some limitations. You cannot do interactive visualization, but there is some way that I'm going to show you how to do that. And the training material has it. So even if you don't have Shine access, the training material has it. It requires a lot of Python type of programming, but it can be done.
Yeah. Mr. Hussein says to slow down a bit in the next session so he can follow up with you. Okay.
I'll be super slow.
Okay. Medat has a question. How to become a permanent Shaheen user?
I think I answered this thing. Let me say it again. So Medat, a permanent user means that you need to have a Shaheen project. So Shaheen Access is project based. So you set up a project, and then while that project lasts for a year or two, you will be a regular user of Shaheen. That's offer is for in-kingdom researchers, and then but if you don't want to go through that process, there is a shortcut that we created. I mentioned that you can go through this consultancy project, and then while that consultancy project lasts, we can help you. But normally consultancy projects are used for people who do not want to do their calculations on Shaheen. They will just say, okay, I made my model, and you just run it and give back me the solution. So that's and the process of setting up a normal Shaheen project, I highlighted it. But again, if it is not clear, you send an email to me, and then I'll follow up with you.
Thank you, Rooh. Abdullah asks, is there a tutorial video for the steps? I think it's there. Yeah.
I'm sorry, I didn't get your question.
Is there a tutorial video for the steps to run the Shaheen?
Yes. So what I should, I mean, first of all, the video is in the training material. You can go to the website. The video is there. But it is a better hands-on session is going to happen in the next minute or so. You will very clearly follow all the steps. So this hands-on session I prepared for people who are actually not Linux expert. So I understand from where you're coming in, and then let's go step by step try to do that.
Abu Bakar has a question. Sometimes the solution doesn't converge based on the residual. So by visualizing the results, we stop the simulation. But in Shaheen, we can't visualize unless the simulation is complete.
Oh, that's related to the earlier question. I agree to what you're saying, but not strictly true, because you can still do batch visualization. So you can while it is running, if let's say you are doing unsteady simulation, you keep on dumping solution after every 1000 time steps, and then you can copy that file, and then you can visualize on your workstation, and then you can steer the simulation back again. But other than that, you can do a batch visualization on Shaheen. I am going to show you right now. And then what you're going to do is that you can see if the solution is diverging or not. Having said all of that, practically how I normally use, or people with very, very large simulation use Shaheen, is that first they nail their problem down to a really stable settings. So they select all the stable parameters, and then when they are very confident that the refined mesh is actually going to run stably on Shaheen, they run it. Because you're right, computational resources are expensive on Shaheen, so you don't want to waste your resources by just hit and try at a large scale. So at a smaller scale, you do a lot of hit and try, and then eventually you will get this intelligence that, okay, I need to set these parameters like that. For example, in the current cavity case, if you set inlet flow 1 and the fluid is air, it's not going to converge. So you have to reduce that the velocity with the mesh that we chose. So because it's too high, the real number is too high. It's around 10⁵. So yeah, but again, you're gonna cover. We are gonna try to cover this thing in the session. Now we are getting squeezed by time. So let's. If I cannot finish it, I'm gonna share this hands-on material, and then you guys can follow. Now I'm sharing my screen. So you will see the hands-on session presentation and a Shaheen terminal. Right, I can see confirm from my laptop. Let me try to make it bigger so that you guys can follow it. All right, so this is for those who are not familiar with Linux. So this problem is a sedan car case. It's a 4 million node mesh problem. It's a complicated mesh. So I assume that we went through all the pain of making the model and putting the boundary condition, and we copied that case file to Shaheen. So I'm not going to go into that part, and we're just going to go into the that part. So those of you who say that Shaheen is difficult, well, it is not, because all you have to do is just type these commands, and then if you type these commands, and you will be able to do all those post-processing, remote post-processing, everything within next 5-10 minutes. So what do you say? Shall we get started? So this tutorial I'm going to specifically be doing for those people who uploaded all their credentials and their IP ranges, and I hope that their IP ranges are set up by our admins in time. A lot of question marks, but I hope that you have your account set up. You will have something like training account information there and the password. If you type those password and the training account information, you will be able to log into Shaheen. Let's go step by step. I'm going to be slow. So this is the command to log into Shaheen using your training accounts. If you don't have these accounts, well, just follow the steps and just follow the demo. And then I also send you the password. Now those people who have Shaheen account and who did not get a training account, they can log in through their normal accounts. All right, now we are logged into Shaheen. This is the step number 1. So what is step number 2? Just do ID. If you do ID, it shows you which groups you are associated with. Specifically, you need to see Ansys in there, and you need to see S1001 is in there. If you see those things, then you will be able to do today's tutorial. If not, then you won't be able to do it. Next step, create a directory. So create a directory in your project. So you do not run your simulations on the login node. So you go and create a directory. So what I did here is that I created a directory with my username. So in my case, my username is KSL_training49. Okay, then I go to that directory which I just created. All right, I can do pwd. This is my directory now. All right, nothing much, just I created a directory, I went into that directory. Now I'm gonna untar a tar ball that I just created for you guys, and you untar it by using this command tar-xf sedan .r. I think the fonts are big enough for you guys to follow it. The untarring is going to take a minute. So while it is copying data, let me revise. I use SSH from the terminal to Shaheen. I provided my username and also my password. And then I created a directory in the project, in my project, which is S1001. And I went into that project. It appears all of you are copying data, so it's taking a bit longer. Okay, I have now copied my data. I'm going into the directory now. CD is a change directory. I'm changing the directory, and then I do ls. So it shows me these directories. So that I have. Now, next step. Step number 5. I'm going to a case. There are 2 cases, one with the 1 node case and one with the 16 node case. I'm going to a CD1 and then I look into my job script. So that's my job script that I showed in the other tutorial also. Now the moment is right for you to launch your first Shaheen run, if that is the case for you. You copy this command and just run it. Okay, there is a problem, so let's So just run this too. Okay, I'm having a problem with this account. Okay, I have to redo this.
Excuse me to interrupt you. I'm also getting some error.
Yes.
Bash sbatch command not found.
No, that would not be a problem. This is something related to the account setting. So what I'm going to do is that maybe there is some issue with account setup. We are running, we are getting on the top of the hour anyway. So can I promise you guys that we will redo this 10-15 minutes tutorial again at another time? Because I really want you guys went through this pain to set up all the accounts. And I think there is some issue either with the IP ranges or I have to figure it out. So I will work with the organizer and I'll get a 15-minute slot to redo this thing. This is really important to redo this example for all those people who want to do a hands-on session. And this will actually give you more opportunity for the new people also to apply for the new Shine account.
Rooh, maybe you can answer the question from Muhammad about sbatch command not found. If you can just put some.
No, sbatch, he has to share his screen. There is no way that sbatch command is not found, because the only way that sbatch command is not found, it means that he was not able to log into Shine. Because if you are doing sbatch on your terminal, there is no slum, so it will give you error. So if you have successfully.
Okay, so let me. So I could easily access Shaheen account, the information you provided, and I'm trying to unzip the files, and it is successfully unzipped. And the moment I execute sbatch, I'm getting this error.
So that's the same error that I got. So this is related to certain options on the account. So this is some accounting related error that we are getting. I'm also getting it. So that's why I'm postponing this session. No, that's why I'm postponing this session. We are going to come back to this that again. In 1 minute, actually, that we have, let me try to revise what we did. We went through the basic of parallel computing. We went into high performance computing. What are the promises Shine can offer to you? We did one tutorial on cavity flow. I agree that was the fonts were small, but you can follow it. If once you have the Shine account, you can follow the whole thing all by yourself. Then we had an incomplete session on the sedan car that we are going to come back and do it again. But this is really very, very easy and simple for first-time users. And I really want all of you guys to respond to my email and help us set up your account, because I only received maybe 10 to 15 responses from external people. I really want external people to respond to my email and upload their documents. I'm going to send you a fresh set of emails so that we can do it again. All right. Those of you who already have the accounts, you don't have to do anything. All right.